For anyone that is curious about an extension, we're going to briefly cover Fibonacci numbers and how they correlate to the golden ratio. So I'm sure many of you have seen the sequence before. We have 1, 1, 2, 3, 5, 8, 13, 21, 34, 55, and so on. This goes on infinitely. So, how is this sequence of numbers created? Well, if you look carefully, each number, for instance 2, is the sum of the two numbers before it, 1 and 1. Likewise, 3 is 1 plus 2, 5 is 2 plus 3, 8 is 3 plus 5, and so on and so forth. So these numbers keep growing and growing at an increasing rate. Now, what is curious about these numbers is if you take this number and divide it by this number, we get 2. And then when you take this number and divide it by this number, we get 1.5, 1.6, and as this sequence goes forward, we have this ratio of n plus 1 number over n number becomes this number, 1.6180339, ... And what is this number? Well, it is equal to 1 plus the square root of 5 over 2. This is known as the golden ratio, and it is very important. Another way of representing the Fibonacci numbers is through rectangles. So if I draw 1 here, a square with an area of 1, and I draw another square with an area of 1, and then I draw a square with side length 2, so an area of 4, and then I draw a square with side length 3, with an area of 9, and then I draw a square with side length 5, with area 25, and then I draw a square with side length 8, for 64. You should see that the side lengths, 1, 1, 2, 3, 5, 8, those are the Fibonacci numbers. And actually, in this scenario, the ratio of this side to this side is 1.6180339. The golden ratio also appears in nature. It's seen on flowers like sunflowers, and it represents sort of like balance. It's also seen in the stock market as well, and shows up surprisingly in many other places. We will see some of this when we talk about three-dimensional objects, even some two-dimensional objects like the ratio of this to the side length of a pentagon, as long as it's regular, and it shows up in many other surprising places.